Let's figure this thing out. So it's really not till part two that I don't.
Yeah, it's part 2 that's the problem.
Yeah. Why does she? I wish she would have given us, because the whole textbook was teaching us how to figure these things out using the SPSS.
Uh-huh.
And this prep has nothing to do with that. It's like having us do it by hand, which I don't understand exactly how to do.
Well, I still used SPSS. I was just confused that we weren't given the standard deviation. So I found it on SPSS. I'm like, oh, that works. But my answer is slightly different than theirs. So I'm wondering if they had a different standard deviation. And by the way, she didn't write the prep guides. That was just written by a board of
Yeah, that's
the
probably true.
course.
That's true. So then did you just take these numbers and copy and paste them into SPSS?
No, oh, you mean like the 15 different samples?
Yeah.
Yeah, I typed them all into SPSS and then I clicked analyze frequencies, and then I made it so it would display, like we can normally get the standard deviation stuff. Everything else they gave us, so I just used that standard deviation, and I got really close to the answer, but it's not the same.
Right. Okay, let me put it in here then. I think if we're somewhat close, that should be good.
Yeah,
It's probably somewhere rounding or something that it just.
maybe. I'm just wondering, maybe we should just go ahead and do the quiz and see if we can. Maybe the prep's just a little bit off. I don't know. That seems unlikely, though.
Yeah. Well, I do want to make sure I figure out this second part. Okay. I have to put it all in there manually. I'm trying to copy and paste, but it's not working.
Yeah.
So 27, 35, 38, 49, 55, 58, 56, 50, 51, 45, 46, 56, 49, 48, 38.
What? I just realized it had 47 as the first value instead of 27, so I bet I could get the same answers as them.
You used 47 instead
On
of 47?
accident, I hit the 4 instead of the 2.
Okay. That could be a factor
So
there.
all you need to do is find the standard deviation and then do the calculation using the t-test formula, and then
Right.
it should be good. So my guess is now I know how to do it.
Yeah. Okay. So I just want to make sure I do. So in order to get the T and whatnot, what does it
Mm-hmm.
say? Where do I go to? It says analyze, compare means one sample t-test.
If you want, I can show you how I did the problem. I can screen share and just walk you through it.
Well, I think as long as I get this box up, I think I'll be fine.
Mm-hmm.
So then for the one sample t-test box, do we have to put in our test value?
Yeah,
The
which would be 47.
47? Okay. So then, okay. Okay, there it is. Standard deviation, did you get 8.827?
Let me look. No, I ignored it with the t-test because it had two different standard deviations listed, and I just did it for just like we would have done before with the z-scores. I just clicked on analyze and then frequencies, and I checked the boxes to make it show the standard deviation.
Okay.
So I got 6.94331 as my standard deviation.
And that's because you used 47 instead of 27?
Oh, that's possible. Let me just calculate it again for here and see if it changes. Now that I've fixed that. Okay. So, yeah, I got 8.82745, the standard deviation.
Okay. Okay, so I get that. Then how do we change the 95% confidence interval to like the 99? And like the different, they're asking us what it would be with a 95 and 99.
Well, so the 95 one. Well, they already give us the t-score for the 99% confidence interval.
Isn't it a 95 that it's giving us?
Well, they give it for 95 in question 8. In question 9, when they want the 99% confidence interval, they gave it to us. They said it was 2.9768.
Oh.
So then we just need to do the same thing, find the standard deviation, and just use that number instead, and it should be.
And we plug it into that equation. Is the equation is the one number 3? The mean minus t times x, or is it the t equals mean minus sample mean?
It's the x take away t multiplied by the standard deviation over your sample size.
Okay. I don't know why this one has an x in there.
Me neither.
That's weird. I'm just going to delete that x. Okay. So basically, you just use SPSS to figure out the mean, standard deviation, and the t-score. And then you use that equation to figure out the interval.
Yeah. And if they give you any of those values, use the values that they gave you, like the one with the standard deviation. That was all we had to find. So we just calculated it like normal because it shouldn't change. Yeah. Pretty much just knowing how to find each variable. You still there, Hannah? Hannah, are you there?
Yeah.
Okay. I just don't see your picture anymore. Or at least
Really?
not a moving one. Yeah, that's okay.
Okay. If you don't mind doing the screen sharing thing and have us just walk through those problems, that would be awesome.
Okay.
Let me get my calculator. Okay.
Okay, which problem do you want to start with?
We can just start on 8. So we need to calculate the margin of error and create a 95% confidence interval to estimate the mean age of all clients.
Yep. So we just barely together on Excel calculated the standard deviation. So we should have all our values.
Mm-hmm.
So we start with X, which is the 47, because that's, and then A, the T.
We subtract, right?
Huh?
We subtract the T-score, so it's
Right.
2.1448.
And we multiply that by our values. So our standard deviation, which is 8.82745 over the square root of 15.
15.
Can you see me typing, or is it not really helpful?
I can't really see it. So, I mean, if we want to just talk it through, that'd be fine, too. You don't have to worry about typing it.
You sure?
Yeah.
Now can you see it?
Yes. It's still a little pixely, but yeah.
Okay. Well, we can talk it through, but I can show you, like, if it's helpful.
Okay.
So let's
then,
just go ahead.
What did you get for that answer?
1 second.
Okay.
So weird not being able to see you. Okay, I got 42.1149079.
Okay.
Is that what you got?
No, I got 102. But I think I messed up the parentheses. But what do you know what the answer is on her prep on the answer key?
Let me look. So the answer is 41.845.
Okay.
So it's almost the same,
to yours.
but not quite.
I think that's good enough.
Okay.
Because technically the mean was 46.73. So maybe because we rounded it there.
Oh, yeah? Oh, yeah, that's probably why. Because that would make it just slightly lower, which would probably make it match.
Yeah. Okay, so 46.73 minus 2.1448 equals 44.58. And then I'm going to multiply that by 8.82745, which equals that, and I'm going to divide it by square root of 15. What the heck? I still get 102.
Okay, so if you can kind of see it, I'll try and make it really big. I'll show you how I put my parentheses, and if you can try that and it works, that might be the problem. So I put it like this other equation right here, which we calculated before. But when I put it in my calculator, I put a parentheses around the square root of 15. That way, I calculate the whole bottom of our equation before we multiply it.
Okay, So
Does that make sense?
8.82745 divided by the square root of 15. I am still getting 101. What the heck?
That's
What am I doing? 46.73 minus 2.1448 times 8.8275 divided by square root. There we go.
okay. I was getting worried. I'm like, okay, I'm going to check my math too.
Well, I mean, the answer is basically that. So
Uh-huh.
41.84, comma, and then we do the same thing, but we add 2.114, right?
Yep.
Plus 2.1448 times 8.82745 divided by square root of 15. 51.62.
Yeah. So that's similar to the one on the. So you got 51.622?
Yeah,
That's exactly the same as the one on the prep guide.
cool.
Yeah.
Okay, I think I'm getting this now. I think we'll be good.
Mm-hmm.
For 9, what are they? Now, 99% confidence interval.
Mm-hmm. So all you have to do is know the standard deviation, which we already found out, and then they've given us.
Oh, okay, I see it.
So it's all the same information except the t-score is slightly different because it's a different percentage.
So then 10, 10B, is that going to be the same thing as 9?
Let me look.
Because it's telling us to use our class software, and I know that somewhere in here it taught us how to,
Do it on SPSS?
yeah, how to change that percentage in SPSS.
Yeah, it's really easy to do. All you have to do, I guess I could show you. So let's just go find some data. So if I were here with my variables right here, can you see this?
Yeah.
Okay, I'm going to go to Analyze,
Uh-huh.
and then I go to Compare Means.
Okay.
Follow that over to the one sample t-test, and I click on that. Then I have my variables in here. If I hadn't already done this, they would be over here, and I just move them over. And then my test value, if I wanted it to be I think I would go 99.
No, look, so you keep the mean like it is there. I clicked on the options box.
Right. There we go. I was like, I've done so many things. So then you would change the percentage to either 99 or 95.
Okay. And then
And
it'd be the lower and upper.
yeah.
So it'd be negative 5.15 and 4.62
For what?
for the upper and lower bound for the 95%.
Oh, okay. I just did it for the 99, so I don't know.
Oh, okay.
Yeah, so should be pretty simple.
Okay. I think I got it now.
Okay.
Thank you.
Mm-hmm.
So, yeah, we can start the quiz.
All right, I'm going to stop screen sharing because I can't see you. It's weird.
You're fine.
Whew. Okay.
Can you see me still, or is it still?
I can see you.
Oh.
Okay. Let me go to the quiz.
God, why won't this leave? Whatever. Okay. Start quiz. $16 questions, not bad.
Okay, you ready?
Yes.
In previous lessons, we had assumed the population standard deviation was known. In this lesson, we are making a different assumption about the standard deviation for the population. What has changed? So we assume that it's not known. Yeah.
Yeah. Okay. For the next two questions, let the null and alternative hypothesis be the mean equals 8, and the alternative is the mean is greater than 8. Assume the population standard deviation is unknown. Becca collects a sample size of 9 and computes 11 and S equals 6.
Okay.
Is it known? Well, isn't it known now that it says 6?
No, because 6 is the one for her sample, but not for like the whole entire population.
Okay.
So the population standard deviation is not known, so it would be no. We know it for the
Okay.
Okay, what is the value of t? Let's see.
So now we're going to use that t equals the mean, the population mean minus the sample mean, divided by that S over the square root of.
Can you say that again?
So we'll go like this. So 11 minus 8 equals 3.
Right.
Then we're going to divide that by 6. So 6 divided by the square root of 9 equals, so 3 divided by 2 equals 1.5. Did that make sense?
Yeah. So we're doing that. I'm just trying to remember where this equation comes from, because it sounds familiar, but I don't remember it.
Be number 5 on the prep guide.
Oh, right. Okay. Gotcha.
Okay. So it should be 1.5.
Sounds good. But we're rounding it, to 1 decimal point. Awesome. Sorry. Okay. Use the following values, which were pulled from the data file body temperature, for the next 5 questions. Copy and paste them into your software. Blech. use the null hypothesis of 98.6 and the alternative hypothesis of less than 98.6 and a level of significance of 0.05. That's a lot of numbers. I hope we don't have to type them all in. Okay, what is x?
Looks like we will. Okay.
You can't even copy and paste it from the quiz. You just have to type it.
Yeah.
Okay. This makes for a thrilling video, huh?
What?
I said I bet this makes for a thrilling video to watch.
Yeah.
Okay, so I finally have all the data entered. Now I just need to calculate for our mean.
Okay. Same here.
Okay, so I get a mean of 98.2200, and I got a standard deviation of 92201, 0.9220.
Mine were slightly different.
Yeah?
Yeah. Let's see. Let me go through the list again, make sure I entered everything right.
Yeah, I'm doing the same thing.
98, 99.6, 97.8, 97.6, 98.7, 98.4, 98.9, 97.1, 99.2, 97.4, 99.1, 96.9. Whoa. Okay, I think I'm off.
Yeah.
99.1. $96.9, $98.8, $99.9, $96.8, $97, $98.7, $97.6, $98.7, $98.2. Okay, let me try again. $98.220.
For what?
Sounds
Oh, yeah. Yeah, that's what I got.
okay. So is that the answer for 6 then?
Let me look. Let's see. 6, yeah. Except it would be 98 point. Yeah. 22.
Okay. 7. What is S?
So that should be 0.922.
Yes.
Okay. Question 8. What is the t-score? So now that we have all the information, we should be able to calculate the t-score. So,
Well, can't we pull it up on the... Because can't we go to analyze, compare means, one sample t-test? What's that? 98.220. And it should give us the t-score.
right. So our test value is our mean, correct?
Yeah.
Or is it something that they already assumed? Let's look. Would our test value be 98.6?
Yeah. So let's just do the what's it called? The equation. So it'd be 98.22 minus 98.6 which equals 0.38, negative 0.38. Okay, and then our S equals 0.922 divided by, what's our sample size? Do we know?
Our sample size, let's see. I guess we have to count how many points are left. Let's see.
So
20.
20?
Yeah.
Okay. So then divide by the square root of 20. So then negative 0.38 divided by that answer equals negative 1.843. Does that sound right to you?
Yeah. I'm just double checking with my calculator.
Sounds good.
So do we divide the standard deviation by the sample size or just multiply?
It's so it's the x bar minus the mean
All over.
s divided by the square root of n.
Yeah, okay. I just wanted to make sure I had it written right.
Yeah, you're good. My phone gets so hot when we're on this video call.
Really?
It's crazy. Yes.
Okay, so what did you get for T?
Negative 1.843.
I got negative 1.713. So
let's do it together again.
Okay, so we have 98.22 minus 98.6, which is going to make negative 0.38. Then we divide that by
0.922,
which is
divided by square root of 20. So for the 0.99 divided by the square root of 20, I just get 0.206. And then I take negative...
Oh, you got negative 1.84, right?
Right, but I'm going to take negative 0.38 and divide it by what I got, dividing this deviation.
But now I'm getting the same answers you got before, so I must have done something.
Huh. Okay. Sounds good. So what is the p-value? Shoot. Well, the p-value, so the alternative hypothesis is saying it's asking for half of the tail. So not both tails, half of them. In the textbook, it talked about this, saying, let me get to it. Find the p-value. Okay, so how do we use the sig two-tailed part on the one sample test outbox to find the p-value? Well, this depends on the alternative hypothesis. Consider each of the following alternative hypotheses. So ours is saying the mean is less than 98.6, right? Hello? We're back. Did it die on you?
Yes, it did. I was like, what just happened?
Dang, that stinks.
Yeah. Okay, where were we? Let's see.
Okay, so we're talking about the p-value.
Right.
So basically what I learned in the textbook was it said we could get the p-value by using on the one sample test out box.
Mm-hmm.
It gives you the T, the DF, and then the sig two-tailed.
Right. So I remember that, and since we're only looking for one, we were gonna have
Divided by 2.
to just divide it in half. Yeah. So it turned off all the SPSS. Do you want me to pull it back up and do it, or?
No. I will be in charge of that part. You poor thing.
Sorry.
No, it's okay. I feel bad for your computer.
It's okay.
Okay. So this is in my third. Okay, so if I get the box back. So the mean was 98.22, all right?
Yes.
Okay. Cool. Here we go. Okay. So it says the sig two-tailed is 1.0. We divide that by 2, we get 0.5.
Okay.
And then we have to compare that to the level of significance. And it's if the p-value is greater than the level of significance, we fail to reject the null hypothesis.
Okay, and it is greater because our level of significance was 0.05.
Yeah.
So we're failing to reject it?
Yep.
Okay.
So for the next questions, it looks like you do need your SPSS, but if you trust me, I do not mind doing it. I already inputted it all.
I trust you.
Okay. Let me close this so we don't confuse it. Okay. I'm going to have you read me the numbers just so I can double check my order. Do you mind reading those for me?
No, not at all. Okay, so 59, 14, 37, 62, 68, 2, 15, 9, 157, 27, 37, 2, 55, 86, 14, 4, 40, 36, 47, 9, and 61.
Perfect.
Awesome.
Okay, so it's having us do the p-value again.
Mm-hmm.
So, oh dang, I have to get the mean first. Okay, one sec. Okay, so the mean is 40.0476. 40.0476.
Okay, I wrote it down, so you don't need to keep repeating if you don't want to.
40.0476?
Yep.
Okay. So it's 1.0 again.
Okay. And this time, we want both tails, so it should just be 1.0, correct?
Yes.
Awesome.
So then it's greater, so we're failing again. Right?
Yeah. That sounds bad. We're failing again. Okay. You decide to try another alternative hypothesis. This time, you use the mean is less than 40 and keep the same level of significance. Did the p-value increase or decrease?
Decrease?
Probably. I'm seeing if I wrote anything down for this.
Because
Yeah.
if it's going to have us divide it by 2.
Right.
So
Oh, yeah, so it should be less.
But this is kind of an interesting quiz. I like it, though.
Interesting. Okay, what decision do you make? It's still greater.
Yeah.
Right,
I
so
hope we're on the
fail to reject it
right
again.
track here. Okay, now construct a 95% interval for the true mean wait time between births at hospital. What is the lower limit of this confidence interval? Are they wanting us to use SPSS or?
I think they want us to use SPSS because in the lesson they had the baby boom. Using that file, then we can use it for the time between births this time.
Okay.
And then it should be the same process.
Okay. So, well, the lower level is going to be negative 16.5490. Well, they didn't even give us the t-score.
Right.
So, yeah, we'll be able to do it by hand, right?
Right. So you said
okay,
it's
so negative 16.5490. So then it's going to be negative 16.5.
Right. Okay.
And then the upper limit is 16.5. It's the same thing.
Cool.
But positive.
Right.
Okay.
We ready?
Ready?
Oh, yeah. 1, 2, 3.
We have to click like, yes, submit, 5 times.
I know. Like, of course I'll submit. 2 is enough. Don't give it to me like 3 times.
Oh, not looking good. We've got a 76.
We missed question 9, question 10, 11, 15,
11?
and 16. That's weird.
What the freak? I said freak. I didn't say beep. I said freak.
I know.
Okay.
That's weird because I'm sure we did everything else right. We did get the correct t-score on number 8. So the p-value should be right. Unless
the
maybe
score we did by hand.
Sorry, what?
The t-score we did by hand. It wasn't in the SPSS.
So maybe if we just did it using SPSS, we'd be able to get it.
But I think if we were to do it by hand, because number 8 we did by hand and we got it right.
Right.
But number 9 we used SPSS and didn't get it right.
I just don't know how to calculate the p-value by hand.
Yeah, me neither.
Because they gave us, for the two-tail, they gave us 1, and we should just be able to divide that by 2. Maybe because it would be lower than, the alternative says lower than 98.6. Would that make it negative? I don't think it would, but
Let's try, because if you look at the baby boom examples in the textbook,
uh-huh.
when it gets to the p-value, so in the output box, it's going to give us the degrees of freedom,
Right.
which is 43, and it's one less than the sample size. So then I think if we use that student probabilities app, the applet,
Uh-huh.
if we put in the degrees of freedom, it should give us both tails.
Mm-hmm. And then we could just
Let's,
select the lower one.
yeah, let's just see. So the DF is 20.
Okay.
So 20. And the T score is, what did we say? 1.8.
We said, yeah, 1.843.
Okay. See, that changes things. So we want to figure out the p-value to the left.
Right. I mean, correct.
So then it's going to be 0.0401.
So did you put
So
in the degrees of freedom first and then put in the z-score?
are you on the applet or on
Yeah.
the? Okay, the one where it
Yeah.
has like that flag on it. It's like a green,
Flag?
white, red flag.
Oh, that one. Yeah.
Yeah. So yeah, you put in 20, and then I put 1.843 on the T score part, and then I only have shaded green the left tail.
So you can actually use that one in the practice
Oh
one?
no, no, I there's a there's a link in the textbook that you have to follow.
Okay. Is the link in the actual quiz or is it in our homework?
I got it from the textbook. Where is it?
Okay, let me look if I can see it.
Click here. Okay, so it's right. Yeah, it's kind of hidden very well.
Yeah.
Um, so it's in the very beginning under section 2, and there's a
Okay.
click here right above those 3 graphs.
Okay.
So that's where it's at.
Huh. That works, I guess.
I'm guessing a lot of people are going to have problems on this quiz.
Yeah, so our degrees of freedom are, you said it was
20.
20? Okay. And then we put in our z-score of and then we only showed the tail end. Okay, I got the same number now.
You got there?
Yeah.
Okay. So if you want, I'm going to open up another window,
Mm-hmm.
and as we go, I'm just going to fill in the answers for our second attempt.
Yeah. Okay.
I'll wait for you.
Thanks.
I'm going to fill in all the answers up until that first one we missed just because we got them all right.
Yeah.
Okay. Are you getting there?
I'm getting there. I'm filling in the answers as well.
Oh, you're fine.
Okay, so question 9, p-value, we're putting it as 0.040, right?
Yeah, that's what I would do.
Okay, awesome.
0.040.
And then for 10, so if we had that, that's less than
it's less. So then we're going to reject it. Right?
Yep, that's right.
Okay.
So now then, for 11, we need to find the proper p-value for them. Wouldn't we just use SPSS for that? Oh, I think I know. Well, nope.
Please tell me, because we only found the p-value for this one because we had the t-score.
Right. So the p-value, I don't know how to figure that one out.
But if we figure out the t-score,
yeah,
it's not asking for it necessarily on the quiz, but we do need it in order to plug
it in. We need it to find the p-value. So we should find the t-score. Yeah.
Right. Go back and see what is the mean.
Yeah.
So it's going to be 40.0476 minus 40, because that's the sample mean.
Right.
Equals 0.0476. And then the standard deviation is 36.35585 by the square root of 21 values, 7.933. So I'm going to take 0.0476 divided by that answer, 0.0059.
Okay, and you said 21 values. Are there 21, not 20?
Yeah.
Okay, just making sure.
Yeah. And then, so we'll plug that into the t-score, 0.005999. 876. I don't care. Okay, that's not what I wanted. That's basically going to be 0.006, yeah. Okay, the degrees of freedom is 20.
So what's the p-value?
Well, when we share, are you getting like 0.5023?
I just need to put in the right z-score. I forgot what it was.
It should be 0.005999876. It's gonna round it automatically to 0.006 on the applet.
I'm getting 0.5024 for the probability.
Okay. So it's wanting us to, we're gonna have to do both sides because of the alternative hypothesis. So it'd be 1.
Right. So that's the same answer we got before.
Really?
I believe so. Let me look.
It is.
Yeah.
Ugh. I don't know what to do for this one. Okay, well, obviously question 12 is reject the null hypothesis. So that's one that we can be for sure of. And then
So for 12, it's failed to reject the null hypothesis.
oh wait, no. Yeah, it is. Yeah, it's fail.
And then we know for question 13 that it's going to decrease.
Yes.
And for 14, we also fail to reject it. 15 and 16 were marked as wrong. How did you find the upper and lower? Did you just put in the...
I did the SPSS way. So
Yeah,
do you want to
so
do it by hand?
that should be right?
I know it should, but
And
it's 95%. But if we can't find the t-score, we can't find the upper and lower bounds.
Well, let's see. If you find the mean of all the information that we have,
right,
then you go and do it, I believe. Then it will give you the t-score in that little box. So you just set the...
right. And it says the t-score, it says t is 0.000.
That's really weird.
So I remember in the reading, it said if the sig two-tailed is 0.00, and you double click on it, oh, okay. It's 0.000002.
Okay.
So let's try, so 5 zeros. 1, 2, 3, 4, 5. So let's try putting that into the 0.00002. Not doing anything.
Better, but not 100.
So we could try this because if we use SPSS for the p value, we're supposed to use the sig two-tailed box.
Right.
Which is 1.
Ah,
So I don't understand.
me neither. Let's see. And you said 0.00002. What value is that? Was it our
The T
that's the t-score?
in the box at least on the SPSS.
Huh. That's really weird. Because we should be able to go to analyze, then go to compare means, one sample t-test, and then it has that little box below it. We would put
Right.
in our 95, right? Nope, that's not it yet. We would put in
Just the mean.
the mean. So we'd want to put in the mean and then click on options and do it at 95% confidence. Did you do that?
Yeah, it's at that.
That's weird. It should be right.
Do we want to just try? We can try the mean. 40.0476 minus 0.000002. That. I'm trying to remember the formula.
So the formula is
And it's time
the mean
standard deviation.
take away the population mean over the standard deviation divided by the square root of the sample size, right?
So the sample size is 21.
Mm-hmm.
Then my other siblings go to
Let me try this one more time. 140.0476 minus 0.000002 times 36.35585 divided by okay. I got 40.047 for the lower part.
Okay.
Because I was thinking patient. Yeah. So I was like patient, but then I was thinking
40.0. It'd just be 0.
So 40.0.
40.04.
04?
Yeah, so if it says round to one decimal place, it'd just be 40.0, right?
Right.
Okay.
What about the upper limit? How are we going to find that? By adding?
Yeah, do the same thing. Let me get back to the value. So 40.047.
I don't care.
5585
okay,
divided by square root of 21. I got the same thing. How does
You
that
did?
work?
Huh. So you were just doing the same thing, but you were
I added it. Maybe
yeah.
I added it the first time. Let me see what that does.
Well, they
It's the
can
same
be the
thing.
same.
They can?
I think that they can be the same. Sometimes they're the same and sometimes they're different.
Basically, you come across.
I think it is slightly different.
Yeah.
Because when I subtract it, it ends in 8413.
Mm-hmm.
When I add it, it ends in 1587.
Monday, I'm not sweating.
You're not sweating?
No, but I'm just sitting there and like people are kind of or I'm kind of laying down,
I mean, they are only 0.5 points.
sitting there.
Yeah.
Yes,
So is it just so small that we're getting the same one for both?
I think so.
Well, then I guess it would be the same answer because we just have to round to one decimal place.
Yeah.
Okay.
You want to try it?
Yeah, but what did we decide for 11? We still couldn't find the p-value.
Right.
Because before we said it was 1, and we kept doing the calculations, and we thought it was 1. So it's strange. We know that we're going to fail to reject the null hypothesis. So it has to be larger than 0.01, which they have. So at least we know that, but
Right.
Okay, so Grand Canyon.
Grand Canyon, he basically come upon us, or me, whatever, I'm resting.
I wonder
First thing about.
Just kind of sitting there.
if there's a way to analyze the p-value.
I don't know. uh, So you used 20 as the degrees of freedom
So I guess that's all you need.
because there's 20 values, or did they say that was the degrees of freedom?
Yeah.
So the degrees of freedom is the sample size minus 1.
Right. Okay, so then that makes
that makes sense. Yeah.
Okay. Yeah, I don't
Okay, you okay?
know where to go from there.
Yeah.
I think so. Fine, I guess.
You finally get it?
Should we do 0.5?
You know it.
What'd you say?
Should we do 0.5?
Sure. I don't know what else to do.
I know, me neither.
Oh, there you go.
Yeah.
Sorry, we done.
I want to meet with Sister Withers sometime.
Hydrated.
Go over stuff like this.
I guess, I don't know.
Okay, well,
I don't know.
ready to submit the quiz?
No,
Oh,
I just finished the hydration.
okay.
Yeah.
Most of the time people are like,
Okay,
oh,
here we go.
because they just
Yeah.
like, oh yeah, the water about an hour ago.
Dang, okay.
Well, we got better than we did before. We only missed 15 and 16.
Yeah.
That means 11 must have been, no, we missed 11 too. Okay.
No, because 15 and 16 was 0.5 points.
Right, okay. Yep, well,
Yes.
that's still okay.
Yeah.
Yeah. Oh well. We did what we could, right?
Right, we did. We tried.
Yes.
Um,
Okay. Well,
so
thanks for helping me, and good luck on your homework quiz.
Thanks. Thank you for helping me. I will go post this right now, so don't forget.
Awesome. See ya.
All right, bye. See you Tuesday.
I just thought